Math 2, Unit 11.2. Today we are going to be talking about multiplying and factoring, specifically factoring out the GCF. You should be on page 646 in your books. As a reminder, there are to be no cell phones out during notes. Everyone needs to be actively taking notes and paying attention. Okay. So still on page 646, basically when you are multiplying here, when you have a monomial times either, this is a trinomial or any type of polynomial, you are using the distributive property. So what they're showing us here is that when you're taking this 2x and multiplying it through, you are multiplying 2x times 3x. And then 2x times 1, and you simplify that to get 6x squared plus 2x. Okay, and so that is the area of that figure. So we're going to go ahead and practice this. And so all we're doing is distributing the 5n to each of the terms. And so to make sure that we do not mess up, I would suggest writing it out just like they did here. So we are going to write 5n times 3n to the third, and there's a minus sign, so we write minus, and next we have 5n times n squared, and this is a plus sign, so I put plus, and we have 5n times 8. And then all we're going to do now is go through and simplify. So we multiply our numbers with numbers, and then letters we can end up simplifying by putting them together. Remember that when your variables are multiplying, you add the exponents. So we multiply 5 times 3, which makes 15. And this is n to the first power, so n to the first and n to the third makes n to the fourth. We have a minus sign. We only have a 5 here. You can think of having a 1 there, and 5 times 1 still just leaves you with 5. Here we have n to the first and n to the second, which will make n to the third. We have a plus sign again. We're going to multiply 5 times 8 this time, which is 40, and there's only an n, so that's just 40n. And that is my answer. Okay, let's move on to page 647 now. And so on page 647, we'll go ahead and do one more together, and then I'll have you try number 2 on your own. So even though this is written on the opposite side, it's still the same thing. So we're just taking this 2b and multiplying it to everything in the parenthesis. And so I'd write this as 2b times b, and we have a plus sign. And next we have 2b times 11. So we go ahead and simplify. This one just has a 2, so I have 2, and this is b to the first and b to the first, which makes b to the second. Plus 2 times 11 is 22b. So this is my answer here. If you want to go ahead and press enter so students get a chance to try the next one on their own. Okay, so hopefully you had a minute to try this on your own. We're going to go ahead and go through. We're multiplying negative 8y to the third through to each of these terms. So you should have written negative 8y to the third times 7y to the second. We have a minus and then a negative 8y to the third times 4y, and then again we have a minus, and we have negative 8y to the third times 1. You'll notice here, and you could have written this differently, but just pay attention to your double negatives. When you multiply those, they make a positive. At the beginning though, we have negative 8 times 7, which makes negative 56, and we have y to the fifth. 3 plus 2 is 5. A negative and a negative, we just said, makes a positive, and I have 8 times 4, which is 32, and that is y to the fourth. Here again, 2 negatives make a positive, and then we have 8 times 1, which is 8, y to the third. Hopefully you got that answer. Okay, this example that I'm going to show you here is not in your notes, but we're still kind of on page 647, and we're talking about how to find the greatest common factor. So I just want you to kind of look at this here for a minute. Again, this is not in your textbooks. Okay, so if we have 5x to the third plus 25x squared plus 45x, and we want to find the greatest common factor of that, you need to think about these terms as split up into basically single items, or yeah, we'll just call them like single items. So 5x to the third, that's really 5 times x times x times x. 25x to the second, when broken down, is 5 times 5 times x times x. And 45x is broken down into 3 times 3 times 5 times x. So all of these are prime numbers. In order to find the GCF, you have to, every single one of these terms has to have the same thing. So if you look here, how this has a 5, this one has a 5, and over here, this one has a 5. So 5 would be part of my GCF. So then we want to see, do they have anything else in common? Well, this one doesn't have any more numbers. So that means in terms of numbers, there are no other numbers that can be part of the GCF, because all three of them have to have the same thing in order for it to be a GCF. So then if you look here, each one of them has an x. Now granted, this one has 2 x's and this one has 1 x, but this one only has, or this one has 2 x's and this one has 1 x. They all have to have it. So the most amount of x's we can take out is 1x, because all of them have to have it in common. So if you look here, the GCF for this term is 5 times x, or also it can be said as 5x is the more proper way. So again, with your GCF, all three terms, or however many terms are in the problem, all of them have to have that number and letter in order for it to factor out. Okay, so still on page 647, I want you to go to problem number 2. So again, we're on page 647. And what they've said here is, under the essential understanding, is that factoring a polynomial reverses the multiplication process. When factoring a monomial from a polynomial, the first step is to find the greatest common factor, also known as GCF, of the polynomial terms. Okay, so on got it. It says, what is the GCF of this equation? So the first thing I always like to do is to first look at the numbers, and then after that, I then look at the letters, or variables. We'll put variables. So I always kind of think of those as two separate pieces. So if I start by looking at my numbers, I have a 3, a 9, and a 12. So I always go to my smallest number, because that is the largest amount I could possibly take out. And I check to see, can 3 go into 9 evenly? Yes. Can 3 go into 12 evenly? Yes. So therefore, part of my GCF will be 3. Now, if 3 didn't work, then we'd try to go down from 3 and split 3 apart to see if one of those numbers could go into all of them. But in this case, 3 worked. So here, when we look at our variables, I have 4 x's, and I have 2 x's, and then I have 1 x. And so if we were to list these out, you would list it out x times x times x times x for the first one. You have 2 x's in the second one, and you have 1 x in the third one. So the largest amount of x's I can take out is just 1 x, because in order for you to take something out, all 3 of the terms have to have it in common. And so basically, the largest amount you can take out is whatever the smallest amount is. And so in this case, my GCF ends up being 3x. Okay, so now practice problem 3. I'm going to give you a few seconds here, or maybe more than that, to figure out what you think the GCF is of this. So again, you look at your numbers first, and then next look at your letters. So if you're looking at your numbers, and if you were to break, let's say 45 down, so let's start a factor tree with 45. 45 breaks down to 9 and 5. Now I can break 9 down further, but I'm going to wait there for just a minute, and I'm going to take 27 because I know that 27 breaks down to 9 and 3. Now I notice, and if I write it out like this, 45 is 9 times 5, 27 is 9 times 3. They both have a 9 in common. If I had split those 9s up, each of them would have had 2 3s in common. So my GCF on this problem is 9. Then when I look at the letters, this one has a B, but this one doesn't. And so since I couldn't take out a B from here, I can't take their GCF doesn't have B in it. So my GCF, for example, 3 is 9. So I'm going to give you another about 15 seconds here to try to see if you can figure out what the GCF would be of number 4. So if you're looking at these numbers, we know that 14 breaks down to 7 and 2. 42 breaks down to 7 and 6. And 21 breaks down to 7 and 3. Now, hopefully you notice that each of them have a 7 in common. So my GCF is going to have 7 in it for sure. Then if I look at the other numbers, 2 can't be broken down. 6 does break down to 2 and 3, but this one doesn't have a 2 in it, so 2 won't work. And this one doesn't have a 3 in it, so 3 won't work. So the GCF in terms of the numbers is only 7. When we go and look at our letters, this one has 4 Z's, this one has 3 Z's, and this one has 2 Z's. So all of them have 2 Z's in common. So therefore, the GCF I can take out is 7Z squared. Okay, we are going to move on now to page 648. So on 648 it says, once you find the GCF of a polynomial's terms, you can factor it out of the polynomial. So we look at problem 3, got it A, and it asks, what is the factored form of 9x to the 6th plus 15x to the 4th plus 12x to the 2nd? So starting with figuring out what our GCF is, you can always break down these numbers if you want to. So we know that 9 is 3 and 3, 15 is 3 and 5, and 12 is 3 and 4. Oops, 3 and 4. Hopefully you notice that they all have a 3 in common. So my GCF is 3, and I can't break any of these numbers down. 4 can break down to 2 and 2, but that doesn't help me with finding one that all 3 of them have in common. And then looking at the letters, this is 6, this is 4, and this is 2. So the most amount I can take out is 2 because all of them at least have 2 x's, and so that is my GCF. What I'm going to do now is rewrite the problem. So I have 9x to the 6th plus 15x to the 4th plus 12x to the 2nd. And we are now going to take out the GCF, which is 3x squared. So when I do that, I write 3x squared, and you make a parenthesis, and we go through and we divide each of these terms by 3x squared, which is my GCF, and we simplify. When I do that, 9 divided by 3 makes 3. So we have a 3 here. And x to the 6th over x to the 2nd, when we're dividing with exponents, hopefully you said subtract, so 6 minus 2 makes x to the 4th. So we're just reducing this, and this becomes a 4th power. Plus 15 divided by 3 makes a 5. And we subtract our exponents, and 4 minus 2 makes x to the 2nd. So we have 5x to the 2nd. Plus 12 divided by 3 is 4, so that's a 4. And then the x squareds cancel out. So this is my factored form of this problem. If you wanted to double check your work, you could always multiply the 3x squared through to make sure it got back to your original problem. You also want to double check your parenthesis here and make sure that they don't have anything in common. So if you look at that, the numbers don't have anything in common, and they don't each have like the same letter. And so you know that you took out the correct GCF. Okay, letter B. It says reasoning. What is negative 6x to the 4th minus 18x to the 3rd minus 12x to the 2nd written as the product? What does product mean? Multiplication. The product of a polynomial, which we know is like 3 or more terms, or 2 or more terms, and with a positive coefficient and a monomial. So basically, do you see how each of these terms are negative? They want the polynomial to have positive coefficients, so we're going to need to factor out a negative in addition to any other numbers that they have in common. So looking at this problem right here, what do you think the number GCF would end up being? So again, I always like to look at the smallest number and see if that smallest number will go into all of the numbers. So we know 6 divided by 6 is 1, so that works. Does 6 go into 18 evenly? And the answer is yes, it's 3. And will 6 go into 12 evenly? And that answer is yes, it goes in 2 times. So for my GCF, we know, and I'm going to rewrite the problem here, we have negative 6x to the 4th minus 18x to the 3rd minus 12x to the 2nd. So for our GCF, we know we're going to take out a negative 6 because we want to divide by a negative in order to make that positive. And then in terms of our letters, our largest exponent that we can take out is going to be x squared. So now I'm going to divide each of these terms by negative 6x squared. And we will simplify. So when we take out our GCF, which is negative 6x squared, we make our parenthesis, and then we're going to come over here and reduce. Negative 6 divided by negative 6, that cancels out and makes a 1. You can write a 1 if you want to, or you don't have to write the 1. And then x to the 4th divided by x squared makes x squared, because 4 minus 2 makes 2, and since it's positive, it stays on the top. Next, a negative divided by negative again makes a positive. 18 divided by 6 is 3. And then when we reduce here, x to the 3rd over x to the 2nd, we subtract 3 minus 2, which is 1, so we get plus 3x. And lastly, 2 negatives again make a positive. 12 divided by 6 makes a positive 2, and the x squareds cancel out. And so that is the product means multiplication, of a polynomial of positive coefficients. So notice all the numbers in front here, those are your coefficients, they're all positive, and a monomial. A monomial is a single term, and so that's the single term there in front. Okay, we're going to go ahead and keep on page 648, but practice a couple more problems here. Okay, so we'll do one more together, and then I'll have you maybe try number 6 on your own. So looking at these numbers, and again, if you're ever not sure, just start doing a factor tree on all the numbers. And so this number is 7 and 2, this one breaks down to 7 and 5, this breaks down to 7 and 4. And so what would end up being my GCF? Hopefully you said 7, because I can't break 5 down anymore, and I In order for me to take out another number, it would possibly be 2, because 4 breaks down to 2 and 2, and you have a 2 here, but I don't have a 2 here. So all 3 terms, or however many terms in the problem, have to have the same number in order to be able to take it out as a GCF. Okay, now looking at our letters, notice here, there's 3 n's, there's 2 n's, and are there any n's here? No. So since there aren't any n's cannot be part of my GCF. So the only part of this problem that's a GCF is 7. And so I'm going to rewrite the 14n to the third minus 35n squared plus 28. And we're going to take out our GCF of 7. So we go through, divide each of these terms by 7. 14 divided by 7 is 2n to the third minus 5n squared, because 35 divided by 7 is 5, plus 4. 28 divided by 7 is 4. And that is your answer. Okay, on this next one here, I was going to have you do it on your own, but for time's sake, we're going to go ahead and go through this together. So looking at our numbers, do you see how this one doesn't have a number in front, which we can say that's a 1? But since this one doesn't have a number in front, even though the rest of them do, all of them have to have the same number in common. So in this case, the GCF number would be 1. But we don't normally divide anything or factor out by 1 because it doesn't change any of those terms. Then if you're looking at the letters, there's 4 G's, 3 G's, 2 G's, and 1 G. So the largest amount of G's that I could factor out of this problem will just be 1 G. So it's up to you. You could write 1 G. I'm just going to write G, and we're going to divide each of these terms here by G. When I do that, G to the fourth divided by G, we subtract, and this is really a 1 exponent with all of these. And so 4 minus 1 makes 3. So I have G to the third plus 24, and then G to the third minus G to the first. 3 minus 1 makes G to the second. Plus, here we have just 12, and then G to the second over G to the first. 2 minus 1 is 1, so you just have G. Here the G's cancel out, and we are left with plus 4. And that is our answer. Okay, turning now to page 650. We're just going to do a couple lesson check problems here together. On page 650, it says, what is the simpler form to this problem? So when it says that, they want you to distribute. They want you to multiply that out. So we're going to have 6x times 2x to the third plus 6x times 7x. And we, wait a second, did I do something wrong? No. Okay. So we multiply, and we go with our numbers first. 6 times 2 makes 12. When we're multiplying, we add exponents, and so I end up with x to the fourth. Plus, here, 6 times 7 is 42. And then x times x, you have a 1 exponent, a 1 exponent, which makes x to the second. Number 10, they're asking for the GCF of this problem. So I'm going to give you about 10 seconds here to see if you can figure out the correct number and letters for the GCF. So if you had a hard time, remember you can always do your factor tree. So 4 breaks down to 2 and 2, 6 breaks down to 2 and 3. Notice that they each have a 2 in common, so my GCF would be 2. And then we look at our letters, we have a to the fourth and a to the second, so the largest amount of a's I could take out is a to the second, because you can't take out more than what you have, and the most I have here is 2. So 2a to the second is my GCF. Number 11, they are asking us to factor each polynomial. In this problem, what would be my number GCF? Hopefully you said 3. And in terms of my letters, it would be M is correct, because there's one M here, so the most I can take out from this is an M, so that makes it the most for the whole problem. So we're going to factor out a 3M, which means I'm dividing each of these terms here by 3M. 6 divided by 3, that reduces to 2. And then M squared divided by M, We subtract, 2 minus 1 makes 1, so we have 2m. Next, we have a minus sign. 15 divided by 3 makes 5, and then the m's here cancel out. And so this is my factored form for number 11. Okay, still on page 650, number 12. Okay, looking there, looking for a GCF. On this one, my smallest number here is 4. Can 4 go into 8 evenly? Yes. Can 4 go into 12 evenly? Yes. So my number GCF is going to be 4. And looking at my letters, I have 3 x's, 2 x's, and then 1 x. And so my largest amount of x's I can take out is just 1. So I'm going to go ahead and divide here by 4x to every term. When I do that here, the 4's cancel out. X to the third over x ends up making x to the second because we subtract 3 minus 1, which makes 2. 8 divided by 4 makes 2, and then x squared divided by x is just x. Plus 12 divided by 4 is 3, and then the x's cancel. And again, double check by looking here to see that nothing is in common. As you can see, nothing is in common there. And then you could also distribute the 4x through and make sure it got back to that original problem. Okay, last one here. They want you to match each pair of monomials with the correct GCF. So if you look here at each of these, they're wanting you to figure out what do these have in common. So in terms of numbers, if I break 14 down, I have 7 times 2, and for 35, I have 7 and 5. So what is my number GCF there? Good, it is 7. And then my largest amount of n's that I can take out there is n to the second. And so that matches right here with B. On the second one, we have 21 n to the third and 18 n to the second. In that one, if we break, we have 7 times 3, and here 18 is 6 times 3. And so each of these have a 3 in common. And then we have n to the third and n to the second, which makes it 3n to the second would be our GCF, which is down here at C. The last one we know is going to match up here, but if you look at the numbers, 7 is a prime number, it can't break down. 9 can break down to 3 and 3, but there's nothing in common. And then same with the n's, there's 2 n's here and there isn't any n's there. So the only GCF that they have would be 1. And if you divide all those by 1, it still stays the same. Okay, last one here. It says write a binomial with 9x squared as the GCF of its terms. So they are wanting you to write 9x squared in front, and since it's saying a binomial, they want something with 2 terms. Binomial means 2 terms in here. So you can write anything that you want to there. I decided to write x plus 1. You could write anything you want to in here, but a binomial, that's 2 terms. And once I wrote it like that, then I am going to distribute it through to end up making the binomial. So 9x squared times x is 9x to the third, and then 9x squared times 1 is just 9x squared. So this is a binomial that has a GCF of 9x squared. And that is it.